Guys, welcome to Java JSM, and in this video we are going to talk about solid principles. Okay, and solid principle is very important. Okay, if you are giving the interview for the product based company, or maybe you are giving interview for the any of the outside of the company in the India, okay, maybe the US, London, whatever the company you are targeting, definitely they will ask solid principles. Okay, so solid principle is very important for the writing any Java classes, for any design patterns. It will help you. Okay, and with the help of this one you can achieve, okay, so many things, which is the better way. Okay, and you can design your interface, your classes, and what are the dependency you are doing, what is the subsets of classes you are doing, what are the method you are creating. Those you can make it in the proper way so that you can extend your application, you can scale your project later. So later, with the help of this, you can expand, you can make your large scales of the project or product. So that is the possible with the help of the solid principles only. Okay, if you are not following the solid principles, at the end or later you can face lots of the difficulty, lots of the things, and again you have to change everything and you have to come back to the solid principles. Okay, then only you can achieve those things. Okay, if you're not good with the go with the solid principles, definitely in the later, for example, your application is developed, everything is done, and later suddenly someone came and saying like, oh, I want this feature also, I want this one also, I want this one also. That time you stuck. What we can do? That time you can write boilerplate code. Otherwise you can do some substitutions. Anyway, you are finding something like, okay, we can anyhow you can go from that. Okay, we can do that. Okay, but at the end, while testing, while scale, while making a big project scalables, lots of the issue you are going to face. Okay, so at least as a developer you have to know about the solid principle. It's a very important. Okay, let's talk about one by one. So solid stands for single responsibility principle. So S for single responsibility principle, O for open close principle, L for Liskov substitution principles, I for interface segregation principles, and D for dependency inversion principle. Okay, so this is the mainly solid full form you can see here, but in the depth, if you know what is the single responsibility principle, what is the open close principles, we can see. Okay, let's go and understand one by one. Okay, so here if you see what is the solid principle is, in Java, solid principles are an object oriented approach that are applied to the software structure design. So whenever you are designing any of the structures, for example, you are designing any of the approach, any of the design patterns, we are following controller, service, repository, like that. We are following, right? In the same way, we can design a structure with the help of the solid principle, like who is the super class, who is the subclass, who is the super interface, after that who is the vested class. You can take a decision with the help of the solid principle. Okay, so because of that we are saying solid principle is a software structure design project. Okay, the solid design principles were introduced by the Robert C. Martin. Okay, he is the one of the authors. He have written these solid principles in the 2000 papers. Okay, design principles and design pattern, design principles and design patterns. So you can say design principles also or design pattern also. Okay, both are combined in the solid principles. Okay, so design principles means we are giving some rules and regulations. Okay, design principles means we are giving some rules and regulations to you to follow this one, that is called a principles. And design patterns means like when we have some requirement, and based on the requirement we can finalize which pattern we can follow. Okay, so that is the design pattern. Solid design principle help us to create a more maintainable. Okay, solid design principles help us to create more maintainable. What is the maintainable? Later if you want to add some more features, that time you can easily maintain it. Later if you want to change some modifications, if you want to do some modification, you want to some change in the response request, then very easy if you go with the solid design pattern. Understandable, very easily you can understood because each and every class will be separate. And flexible software, it means that we are not writing everything inside one classes, we are expanding it, we are writing each and everything separate. So if requirement came to change, even we can add some existing classes, or even we can add some more classes. Okay, and through that we can achieve our whatever the requirements we have, so that is called a flexibility. So it's a very flexible if you follow the solid principle. These 5 principles have changed the world. These 5 principles will change the world of the object oriented programming, and also change the way of writing a software. Okay, also change the way of writing a software, because earlier we are writing a software in the any way, we are not following any standard, we are writing a code blindly, and later we are facing lots of the issue, lots of the maintainable issue, lots of the changeable issue, lots of the flexible issue we are facing. But now the people's, every company, every project, we are following the standard patterns. First we are looking with the solid principles. If it is okay, then we can go with any of the design patterns and we can write a code for it. It is also ensure that the software is modular, easy to understand and debug and refactor. So whatever the issue will come, maybe the production or maybe the release, you can easily find out, you can easily debug it, you can easily refactor it. Okay, so all those possibility will happen with the help of the solid principles. Let's go. If you see the solid principles in the one line, okay, so if someone asks you, maybe the interviewer, hey, do you know solid principles? So you can simply say that yes, I know solid principles, and solid principles having a 5 way to represent it. And solid stand for like single responsibility principle, and the single responsibility principle say that a class should have a single responsibility. It means that one class having a one responsibility, one class having a only one way to change it. Okay, only one reason to change it. Okay, so that is called a single responsibility. The class will not change every time, only single responsibility having a class to change it. That is called a single responsibility principle. What is the open close principles? You can say open close principle. The next is a open close principle. Open close principle means open for extension. It means we have created one interface, and those interfaces open for extension, open for implementations, but closed for modifications. In those interface you can't modify. Those we have blocked. Okay, you can just implement those interface and you can create your own class and you can use it. That is called open close principles. Okay, we can understood one by one each and everything. Okay, but for the quick introductions about the solid principles, you can give this definition. A class should have a single responsibility, single region to change, open close principles, open for the extension but closed for the modification. Liskov substitution principle is it means that substitutions of the object by instance of the subclass. For example, we have a one parent and we have a 2 subclasses. So parent is capable to store the subclasses object, whatever the parents is available, whatever the subclasses is available. So that is called as substitutions of the object by the instance of the subclasses. Interface segregation principle, that means many client specific interface instead of one big one. Okay, so for example, we are thinking to design some of the database, and in that database we thought like, okay, for this database we have a separate type of the connection, for this database we have a separate type of the connection, so we can't create one interface and we can put all those JavaScript method. That is a wrong way. So for the based on the behavior, based on the parameter changes, we can write one interface, sub 2 interface, sub 3 interface you can write, and based on the behavior you can implement it. So that is the good way to go with the interface segregation principle. I will explain later. Dependency inversion principles means what? Depends on the abstraction instead of the implementations. So dependency inversion principles is mean by it depends on the abstractions. It will provide the abstractions, but instead of the implementations, we can't give the implementation. He will provide the abstraction. That is called a dependency principles. Okay, let's go and understand what is the single responsibility principles. So if you see here, the single responsibility principles state that every Java class must perform a single functionality implementations of the multiple functionality. Single functionality implementation of the multiple functionality in a single class mashup. The code, if the modification is required, may affect the whole classes. It precises the code that the code can be easily maintained. And let us understand the single responsibility principle through the example. For example, I am a developer and I am going to design one class which is a student. And in the student class, I have written one method called print details of the student, calculate percentage. Those I have written in the same classes, and also I have written one more method called add a student. So this is the method I have written in one classes, which is a student classes. That is fine. But with if you see, with the help of the single responsibility principles, we are breaking this. We are breaking this principle, single responsibility, because we have written three method inside this student class. But that is not a good way to provide the solutions. Okay, so this is the one problem. So I have defined as a problem. Single responsibility principle said that you don't want to write each and everything inside the one classes. Make it separate classes. That is the single responsibility principles. Make it only one region to change. But here if you see, if I get any changes in the print details, we have to change it. Any calculate percentage, we have to change it. We have to add a student, change it. This is the three things we are doing, three region to change. But I don't want three region, only single region to change the class. That is called single responsibility principle. Let's see the solution, how we can resolve this solution. So if you see in the one class is having a three method, that is the one problem. So with the single responsibility principle, say that break it into the three classes. Each class is having our separate requirement. That is called a single responsibility principles. Okay, so if you see the student classes, the student can only add the student. That is the one single responsibility. Print student details, having a one print details classes, they will only print the details. Percentage, having a one calculate percentage, so we have a separate classes for the percentage. It will just calculate the percentage. So we have created three classes and three classes are separate, so that is called a single responsibility principles we are flowing. So later, not later, after 10 years, after 20 years, if our project is very big, very hug amount of the code we have written, and if you want to simplify it, you can just easily simplify, you can just easily debug it. But if you write each and everything inside the one classes, you can't do it. Maybe you can face lots of the issue and you cannot able to do it also later. Okay, so this is the solution of the single responsibility classes. I hope you understood. I don't want to create a class and I will show you again in the Eclipse. That is your work. So you can create a one classes, write three method, again separate it into the separate classes. That is called the single responsibility principle. Let's go and understand open close principle. What is the open close principle? Basically, the application or module, entity, the method, function, variable, etc. The application or module, maybe the entity, method, function, variable, etc. The open close principle states that according to the new requirement, the module should be open for extension but closed for the modification. The extension allow us to implement new functionality to new module. Let us understand the principle through the example. So basically, if you see, we have a one vehicle info. So vehicle info is a one class, right? And has a method called vehicle numbers that return the vehicle numbers. Sure, okay, fine. So this is the vehicle info class, and this having a one vehicle numbers, and it will take object as a vehicle. So vehicle is maybe the any of the classes, which is maybe the interface, and having some implemented classes like a car or bike. Okay, so vehicle is a one super interface, and this interface is implemented by the car or bike also. Okay, so with the help of this class vehicle info having a method called vehicle numbers, we are calling this vehicle numbers and we are passing one object which is maybe the car or maybe the bike, right? And through that we are getting those bike or car number. Correct? But the problem is, when right now it's a car or bike. Okay, now again, if the feature will come, if requirement is come to add one more, what I have to do? I have to write here one more if conditions, right? I have to write or not? I have to write here. I have to write one more if condition if vehicle instance for bike, car, scooter. That is also possible. A scooter which is going with the current. We can drive with the electricity also. Okay, so that is the one problem. So we can see here. So what open close principle said that, hey, don't write like that code. Okay, don't write like that code. This is the one problem. Later you can face lots of the issue. Each and every time if you add any of the other bike or car or some other van, Okay, so that time every time you have to change this method, that is not a good solution. Okay, so the problem is this one, and what is the solution? So let me talk about the problem. If you want to add another subclasses named called truck, simply we add one more if statement, okay, that violates the open close principles, right? Let me go to the Eclipse and I will show you. For example, this is the test classes I have created. I have to create two more classes. Okay, so I have created one class called vehicle. But before going to create a vehicle, vehicle. Okay, and vehicle class is not a class; it's a interface, and this interface is implemented by. Okay, this interface is implemented by car. Okay, car class implements car, not vehicles, and in the same way I'm going to create. Okay, so maybe this vehicle class having a one method called numbers. If I show you here, you can see, because we are calling internally get numbers, so we have a one method calls int number or get number. Okay, let's understand the problem. Numbers, get numbers, and this class we have implemented in the car, so car have to provide the implementations of it. So for example, car having a one number, okay, which is 100. Okay, and I have created one more class. Which is one I have created car, one is I have created bike. Okay, and bike also implement same interface, which is vehicle. Okay, and they have to implement those method. And what is the number of this car? This bike is 200. Okay, 2001. And this car is 2001001. Okay, correct. So bike is ready, car is ready, and we need one more class. Which is vehicle info. Okay, vehicle info having a one method called public vehicle info vehicle number. Okay, and this vehicle numbers will take one object of vehicle, and here what they are doing is they are checking if, and return type is what? Return type is int number. Okay, so what is the return type? What we are writing here? We are checking if vehicle stand for VAH. If vehicle in a stance of what? Car. If vehicle instance of car, then what we are doing? You can, I hope you know the instance of method. It will check if this object is equal to this object. If they have sent the car here, and if it is car, then this if block will be true, and it will return what? Vehicle like this return vehicles dot get number. Okay, and if it is not, we can write one more if conditions. Vehicles instance of what? Bike. If it is bike, then what we can do? We can return vehicles. Oh my god, what I am writing? RETURN return vehicle dot get numbers. Okay, so corresponding bike it will call and it will give the numbers, and finally if it is not, we can return 0. Okay, so this is the code we have written. So as of now, what we have a bike, we have a car, and vehicle is an interface, and this is the vehicle info. So whenever if you test it, what we can do here, we can write one main methods. Okay, and here we can create one vehicle info equal to new vehicle info object. Okay, and then after, whenever you call it, so vehicle dot vehicle numbers, and here we have to give one object which is car object. So once you give the car object, it will return the vehicle numbers. Okay, those vehicle numbers you can easily store here and you can print it. Okay, but if you see, we have written all those code. Okay, for the car, for the bike, and superclass is vehicle, and this is the vehicle info, and we are able to test it also. If I run it, you can see the output also, no issue in that. Let me run. So if I run with the Java applications, you can see what is the output. Okay, so this is the output when you pass this object, right? This is the output. So right now this is the output 1001. If you pass here other, like maybe the bike object, okay, and again if you call it, then that time you can get 2001, which is the bike numbers. But the problem is, when later someone came and he say like, hey, we don't want only bike and car, I want truck also. So that time you have to create one more object which is truck. So let's create one object called truck, and truck also implement which one? Vehicle, right? Vehicles, and he also have to implement the same, and he also having some number, so 3001. Okay, this is the number having a truck, but only changing this one, we can't use it. What we have to do? We have to change inside the vehicle info also one more if line you have to write here, and what we have to do, we have to write here if it is truck, but if you are changing something inside the vehicle info, solid principle is saying this is not a good design of the code, that is the wrong way to write a code. That is the issue. Okay, that is the issue. So what we can do, so let's see what is the solution. So what we have done is we have added one more, but it's valid means it's not accepting, so it's violates the open close principles. The only way to add the subclasses and achieve the goal of the principle by overriding the vehicles numbers method, as we have so below. Similarly, we can add more vehicles by making another subclasses extending from the vehicles class. The approach would not affect the existing application. Let's go. Solution will be directly we can write a vehicle info, and inside the vehicle info we can call directly the vehicle implemented class. Okay, we can remove the instance of writing all those things, and we have already inbuilt classes we have ready. So let's go to the Eclipse and we can resolve our problem. So what we can do is, here we are not going to write all those things. Okay, we can remove it all those things, and simply we can write here what vehicles. Okay, and vehicles dot get numbers we can call, and we can return it. What will happen now if you go to the test, and same thing we are sending here also, and if you print it, okay, let me show you. So let me erase this value and let me run once again. So you can see here, if I send bike or truck, whatever, okay, if it is truck also, you can get the proper value 3001. Okay, 3001. So like that you can test. So here what we have done is we have removed the complete functionality which we have written previously here. Okay, these things, because it's not required to comparing each and everything, because we have sent here the vehicles implemented object, so corresponding those object it will call automatically. So no need to write a code, all those things we can just write a vehicles. Okay, so that is coming on the interface segregations. Okay, the open close principles, and this is the get numbers. Okay, get numbers. So I hope guys you have understood this example also, like what we have done. Okay, for the solutions. Okay, and open close principles we have understood. Instead of writing all those things, that is the bad practice, we don't want to write like that. Directly we can return it. And also we have to focus on this, like module is open for the extension but closed for the modifications. Okay, let's go and understand Liskov substitutions problems. Okay, that is very important also. Okay, the Liskov substitution problems is cover the before two parts we have learned already: single responsibility principle, open close principle. So this is the combined, it will support Liskov substitution problems. Okay, what they are saying, the Liskov substitution problems was introduced by the Barbara Liskov. It's applied to the inheritance in such a way that the derived class must be completely substitutable for their base classes. Okay, in other words, if class A is a subtype of class B, then we should be able to replace B with A without intercepting the behavior of the program. Yeah, that is happened here also. We have seen in this example only, we are passing which object? We are passing here truck object, right? But we are able to accept here in the vehicles. So vehicle is what? Truck parent. Okay, so if you see here truck class, so truck parent is who? Vehicles. So vehicle is capable to store the truck object without any issue. That is called a, they are saying, okay, it is able to accept those. Okay, it extends the open close principles. I already told you, like Liskov is a combinations of single responsibility and open close. So it will combinely, and also focus on the behavior of the superclasses and subtypes. So we should design the classes to preserve the property unless we have a strong reason to do the otherwise. Let us understand the principle through an example. Let us discuss the problem. So we have a one banking application and we are supporting two types of the account. Right now, if you say one account is current account and other account type is saving account type. If you see to the go to the ATM and you can see they will ask your current account or saving account. So these are the represented by the classes, and we have a current account and saving account respectively. The bank app withdrawal service serve the withdrawal functionality to the users, correct? So if you see in the diagram here, we have a bank app withdrawal service. So through that we can withdraw our amount from our bank. Maybe it's a current account, or maybe it's a saving account. Current account having one method called deposit and withdrawal. Saving account also having a method called deposit or withdrawal. Unfortunately, there is a problem with the extending the design. Okay, the banking app withdrawal service is aware of the two concrete implementations of the account, right? Therefore, the banking app withdrawal service would need to be changed every time with the new account type introduced. So as of now, maybe it's a two current account or saving account. Maybe someone added one more account. So what will happen? Again, the whatever the code we have written, it will break. Okay, and maybe the other account having some only withdrawal method or only maybe the deposit method. So that time our code will be break. But let's see the problem. So let us redesign the solution to complete with the open close principles. Okay, so if you design like that and if you use here, so maybe the next will come. Again we have to write the code here also, banking app withdrawal service. Okay, but if you rewrite, like you can create a one account, and if you follow the open close principles, so you can create one account which is interface having a two method deposit withdrawal, and we have implemented current account and saving account. Okay, and those class will implement this interface which is account, and they will provide the implementation of deposit method or withdrawal method, right? Okay, but what will happen? Principal close banking withdrawal service. So modification when new account type are needed. But the problem is when new account type is needed by using an account based class instead of some other classes. So here we introduce a new abstract account class, that is current account and saving account. Extended the banking app withdrawal service no longer depends on the concrete account classes, because it now depends on only the abstract classes. It's only not need to change when a new account type is introduced, correct? Consequently, the banking app withdrawal service is open for the extension with the new account type but closed for the modification. in that the new types does not require it to change in order to integrate. Okay, for example, we have a one account, maybe it's a abstract, or we can make it interface, no issue. Having a two method, one is deposit, and deposit is a what, one methods, and we have a one another method which is withdraw, and this banking app withdrawal service is implemented such a way that account will call with the object, we can call the withdrawal methods. So now let us look at how in this design a new account type might violate the Liskov substitution problems. Okay, so in that way they have designed the bank app withdrawal service, so through that we can withdraw the amount. Correct? Correct. Let's go and see here. The bank now want to offer a high interest earning fixed term deposit account. Now the bank is allows that we are offering one more interest earning fixed term deposit account. It's a customer. To support this, let us introduce a new fixed term deposit account class. A fixed term deposit account class, as a developer we have to create this class, fixed term deposit account class. A fixed term deposit account in the real world is a type of account. Real, right? Yes, it's account. This implies inheritance in our object oriented design. Correct? So let us make fixed term deposit account as a subclass of the account. Sure, we can make it. But the problem is when you write public class fixed term deposit account extend account, override all those methods. Okay, so far so good. However, the bank does not want to allow withdrawals for the fixed term deposit account. But if you see, previously we have seen two accounts, which is current account or saving account. In that we can withdraw the amount, no issue. But fixed term deposit account, if you add here, in that you don't want to provide what, withdraw method, because if you fix deposit, if you are fixing some amount into the bank for the 5 years, we don't want to provide a withdraw method so that you can withdraw it, right? So when you introduce the new method which is fixed term deposit account class, can't meaningfully provided the withdraw methods, right? So account defines one common work around for this to make fixed term deposit account through an unsupported exception. In this method it cannot fulfill. So what we can do is we have written one methods. Okay, here if you see public class fixed term deposit account extend the account, and we have override deposit methods, and we have override withdraw methods, and in the withdraw methods, if customer call this method withdraw, we can throw one exception, unsupported operation exception. That is fine. Through that also we can resolve the problem, but the problem is withdraw are not supported by the fixed term deposit account, and why you are showing the withdraw? Okay, and if he got some exception, he will frustrate, he will not trust on our account, right? So we don't want to throw any exception while he call the withdraw. So how we can design our banking account? This one, and we can add one more fixed term deposit account so that it will not impact in our code. Okay, how? So this is the final design solution. If you see, so we have a one account. So for the account we can put deposit, because deposit we want in the current account also, saving account also, fixed term deposit account also. So in the account is interface having a common deposit method, but we have to create one interface for this current account and saving account, and in this interface we can provide deposit or withdraw both, and fixed term deposit account will only extend or implement the account classes, and he have only deposit, but we are adding one more layer here, withdrawable account, which is maybe the restrict class we can use, and we can use interface, and through that we can banking app withdrawal service will not impact on those, and easily you can use the current account or saving account, and we can withdraw and do the operations. I hope guys you understood Liskov substitution problems. Okay, and that is a part of the solid principles. Okay, let's see some simple examples so that you can understand. So this is the simple example, this is the bad example, and how we can modify this bad to make it good example. So for example, we have a one class bird, and bird having a one method called void fly, and it's a implemented method. Okay, we have provided the body here, and one more method we have ostrich. Okay, extend the word, and here we have provided our own implementations. It means we are providing the overriding, right? This fly method. So cannot fly violates. Okay, what will happen here? It's violating the Liskov substitutions problem issue. So what we can do, we can create one interface, and inside the interface we can create one interface as a bird. We can provide fly method which is unimplemented, and then after whatever the birds are there, we can, those birds are able to implement bird class, and they will implement our on fly method. Okay, that is the Liskov substitution problem issue. Let's talk about, because I'm not writing a code guys, because if I write a code it's a very big video it will become. So I'm trying to make it simplify so that you can understand. Okay, let's go and understand interface segregation principle. What is the interface segregation principle? Interface segregation principle is clients should not be focused to depend on interface. They do not use keep interface small and focus. Okay, so it's our responsibility to make interface as a simple. So bad example is like we have a one interface called worker, and worker having a two method, one is work and one is it, and we have a different type of the employee, maybe the engineer, maybe the some HR, maybe the some doctors, different of the employee we have. Okay, and one employee having a behavior called they will work more, and some employee having a behavior called they will eat, they will not work. Okay, like that happen. So what we have done is we have created one class engineer and implemented the worker. Even engineer is doing work, he will eat. Okay, he will eat also. So that is a wrong design we are saying for the interface segregation principles. What we can do is for worker we can create another interface, and for eatable peoples we can create another interface, and based on the requirement of the employee they will implement, right? So if you see the good example what we have done, for workable people we have created work methods separate, and for the eatable people we have created one eat method separate. So if class engineer is implements workable, if he want eatable he will implement. If somebody peoples want only workable, he will implement workable. If somebody peoples want eatable, they will implement eatable. So that is the good solutions for it. Okay, and like that we can segregations of the principles we can achieve with the help of the interface. So basically these principles tell us to create more interface, make it more loosely coupled, make it more reliable, so that it's a segregation principles. Okay, let's see what is the dependency inversion principles. Okay, so I hope you understood. Okay, but let's talk about the dependency inversion principle. So DIP, it's a high level module should not be depend on the low level modules. Both should depends on the abstractions. Abstractions should not depend on the details should not depend on the abstractions. Correct? I hope you not understood, but believe me, high level modules should not depend on the low level modules. This thing is very clear. Both should depend on the abstractions, and abstractions should not depend on the details should not depend on the abstractions. So this is the clarifications we are saying, like we have to build our project like it will not depend on someone. Okay, so that is called dependency inversion principle. What they are saying is, in the bad example we have a light bulb. Okay, a light bulb having a two method, turn on or turn off. We have provided the implementation also light bulb. Okay, when we are switching, we are using the switch and we are doing switch on or off, that time we are passing one object as a switch, and here we have given light bulb, so it will only light bulb, right? It's only a light bulb, and the object will created and then we can operate it, okay, based on the conditions. But if you see here what they are saying is, in the good example, create an interface switchable, okay, and provide the two method, turn on or turn off, not like a class, and provide the implementation in the that time only. And now create a light bulb and provide the implementations. So some bulb are light bulb, some bulb are something like automatic on off, like that. Okay, and based on that we can provide the implementations, and then after whatever the bulb will come here, switchable, So every bulb have to implement, maybe it's a light bulb, it will implement switchable, maybe it's a current bulb, maybe it's electricity, maybe the solar bulb, whatever the bulb, they will implement switchable, and here we can provide the switchable device, and they will pass the switchable device parameter while creating an object of the switch, and that time we can store, and then after they will do the turn on or turn off. Not like that. If you see, this is the dependable, you can use only light bulb, we can't use any other bulb. But here if you see, it's a switchable device, and switchable device is what? It's an interface, and interface can implement multiple classes, and they will pass dynamically subclasses object, and they will use it. So this is the nothing but a strategy design pattern. So if you watch my strategy design pattern, you can understood this pattern how they have implemented. So that is called dependency inversion principles. So here if you see, having a dependency, if you introduce any new bulb, again you have to modify switch, and you have to do like that. But here if you see, if you add any other type of the bulb, maybe the sun bulb or maybe the solar bulb, then you can just implement the switchable, and we can pass the object, they can use it. But here it's a tight coupling, and here you can see loose coupling. With the help of the interface we can achieve. And here we have a class, and we are not able to achieve the loose coupling here, but here we are able to achieve loose coupling. That is called dependency inversion principles. I hope guys you understood solid principle in Java. Okay, single responsibility principle, open close principle, Liskov substitution principles. One more times I will show you this one. Okay, single responsibility principle is what? One class having a only one responsibility. Open close principles means what? Make it interface and provide the extension. Okay, so open for the extension, provide open for the extension, but close for the modification. So modification we can't provide, we can just provide the extension. Liskov substitution principles means what? The base class is able to accept subclasses object. Interface segregation principles, many client specify interface instead of one big one. Okay, so based on the your interface we have to implement your classes. Okay, dependency inversion principles depend on abstraction instead of implementations. Okay, so always depend on abstractions, it means loose coupling, not tight coupling. Okay guys, so I hope you understood solid design patterns, and it's a very impactful video. Okay, so don't forget to like and subscribe. Thank you so much.